Welcome everyone to the June 10th OMR Architecture Meeting. Today we have a couple of compiler topics to discuss. The first is issue 5991, which I will talk about, and I need to share my, one moment, please. Okay. So I'm just going to share my share the issue here. So this issue came about because of it was some recent investigation that I was doing that involved pouring through a log file and working with a debugger and really discovering that we have a very inconsistent representation of addresses in the log. Actually, this is the PR. The issue is here. So basically, there is no consistency, essentially. There's different ways of printing hex addresses, and it just doesn't provide a very consistent look and feel to the logs. And the thing that perturbed me in that particular instance that I can think of was I couldn't just cut and paste an address from the log into a debugger and get something. I always had to prefix it with a 0x, which was getting kind of annoying. So I thought that we should probably go through and come up with a consistent address format. So this is not the first time that this has happened with the compiler code. I think almost 20 years ago now, maybe 2002, something like that, maybe 2003, there was an effort to provide a consistent address format specifier for use throughout the compiler. The challenge there was that we were getting the same problem across different build compilers, and we wanted to have some means of standardizing that. So at that time, got a bit more background here. At that time, there was a macro introduced into the code called pointer printf format that still exists to this day. There's quite a few uses of it in the code, mainly in the RAS folder, and that particular macro was intended to be used anytime you wanted to print an address, and different compilers, different build compilers would define that to whatever it needed to define it to in order to make to come up with some kind of a consistent address output. So, a 0x followed by some address. There was some adoption of that early on, and a number of places were changed in the JIT to use that, if not all of the places. I don't remember if that was the case, but a lot of the places were changed. But in that time, I don't think it's really been, other than that initial effort, I don't think it was really widely adopted. And there's perhaps some reasons for that. Awareness is one thing. People need to know that it exists to use it. Convenience is another. People, when they're writing out addresses for a message that they're producing, that maybe that they're only going to think that they're only going to consume it, they print it out in the format that they want, and so on. So, but I think that in order to go through this exercise of producing a consistent address format, I thought that it would be maybe useful to reintroduce or revamp that macro that we have. So for one thing, I wanted to make it a bit shorter. So what I ended up doing was just in this, and I didn't go too far with this, by the way. I just I did a little bit to see how it looked, and then I wanted to get some opinions on how things looked. So I essentially just created a sample PR here. It's not intended to be committed at all. It's just to demonstrate code for people to look at. And once there's some consensus, then we can go ahead with more changes. But essentially, I renamed that to TR format specifier pointer. It's got a prefix of TR mainly to keep it in the TR namespace, but I'm not particularly wedded to that because it does make it a bit longer, so I could drop that. But yeah, it's intended to be used in places where we're printing an address into the log, and those addresses actually come from two different kinds of variables. One are true C++ pointers, and then the other are addresses that are stored in some integral type, such as a uint pointer. There may actually even be cases, actually I know there are cases where addresses are even stored in int32s on some 32-bit paths, or in int64 on some 64-bit paths. So I mean, obviously fixing those up might be worth doing as well from a getting them to use pointer types, but that's not the purpose of this particular PR. So any format specifier that we use has to kind of handle both C++ pointers and integral types. I kept the macro mainly because I like the idea of a macro, because if we ever do decide to change the format of the pointer for whatever reason, or if a particular platform wants to change their format, they can simply just redefine the macro, and then a couple of other helper macros if necessary in order to affect that change. And the way that it's currently defined is that the TR format specifier pointer is it really is defined to be the OMR PRIX pointer, which maps to the C++ standard PRIX pointer, which is available in most of our build compilers these days, if not all of our build compilers these days. But the one challenge with using that as your format specifier is that you have to provide some casts of the data that you want to print in order to eliminate compiler warnings. And compiler warnings, if I mean, maybe Philip will mention that in a few moments, but if you're not already aware, warnings are now enabled. Warnings are now treated as errors when building the JIT component or the compiler component on x86 platforms. So whatever is done here has to be done such that it doesn't introduce a warning. So casts are going to be necessary in some circumstances. So in order to do those casts and to keep things as concise as possible, I introduced two sort of helper macros that you pass in the value that you want to print, and it'll do the appropriate cast for you. So the first is if it's a C++ pointer type, you have to cast it's a pointer to a format specifier pointer. And if it's an integral type, like a uint32 or something like that, you need to use int to format specifier pointer. So I define these in env_types.h. And then I essentially went through all the places right now, or maybe not all of them, but a number of the places that have been using pointer printf format. And I basically replaced those with using the TR format specifier pointer plus one or the other of these cast macros. So just wanted to introduce that and get people to maybe look through the changes that have been made. I didn't realize it was 45 files. That seems large. Wow. But just because this is nowhere near, this is just a dent in the number of places that would have to get changed. But just want to get your feedback on how those look and what you think of the overall approach. So perhaps we don't necessarily have to discuss that right now, but certainly over time, as you have comments, please drop them in the PR or the issue, and we can discuss it there. One other thing that I wanted to mention as well along this lines, I guess going back to the original attempt at doing this when the pointer printf format was introduced was how to ensure that going forward we maintain, we continue to do this for messages that get printed to the log And I don't have a great answer on that, other than, as developers and committers, we need to be diligent on spotting those in pull requests that are coming up. There is even the possibility of adding some linter tooling as well to detect these kinds of things, to detect the use of, for example, %p as a format specifier in strings, and then issuing a warning there. I'm not super keen on that idea, only because there may actually be legitimate reasons or legitimate places where you do want to have a %p in messages that aren't going to the log. So I don't want to introduce that kind of thing, but who knows? Anyway, I'll stop there for a sec to see if there's any questions or initial comments on this proposal.
So separately from the issue that there may not always be a 0x depending on your platform, %p seems like the lightest weight, easiest, most convenient, and warning-free way to print a pointer. And if you print pointers with %p, then they'll come out in a consistent format in a single log, right?
That's right. There were issues, and it's so I guess two things to that. So one is, not all of our pointers are not all the addresses that we want to print are pointers, like they're coming from a pointer to something. They're actually represented as an integral type, which would need a cast to a pointer, I think. I guess cast
Right,
of
and then we end up with
maybe.
people using %x or something else instead.
Yeah. So that's one thing. And then the other thing is, even with %p, I think we're getting different. That is I guess, a compiler implementation defined. Like there's no standardization on %p, and we are, at least at one point, we were seeing different outputs based on the compiler that was being used. So I think that was what was driving the use of pointer printf way back when. So. But if we want a consistent look and feel across the different build compilers, I don't know if we can rely on %p to do that.
Right, it wouldn't be consistent across build compilers. Only within a particular compiler. The thing that I find the most annoying personally, for whatever that's worth, about the pointers is that when they are printed inconsistently within the same log, and then it messes up searching.
Yep.
And you have to
case insensitive.
You have to set case insensitive on purpose, and then you have to manually strip the leading zeros because sometimes they're not there. And
yep. Are you proposing that we explore a %p solution?
I guess I'm not proposing anything in particular. I guess I just I'm not looking forward to writing these extremely wordy macros everywhere instead of %p, just so that we can avoid the warning.
Yeah, that's that is a drawback for sure. If there's ways of reducing the size of these, certainly be willing to consider that. But the other thing about, like I mentioned before, I think you're gonna have to introduce a cast of some sort for the things that just aren't pointers at this point.
Right.
Oh. Okay, so the sample is here. Any feedback? If anybody has any feedback, please comment in either the PR or the issue, and we'll see where we can go with this. The one little wrinkle in all of this as well, or the challenge in all of this, is that there are a lot of places to change. it's not just a matter of finding all the percent Ps, it's finding all the the other ways that addresses are being printed, like you said before, with the percent X's and the percent LX's and all these, there are places that are using PRIX pointer already, and so it's a real pain going through that. But I think that can be done sort of slowly over time as it gets cycles to do that. Okay. So if there's no other discussion on this particular topic, then I'll just stop there for that. We can move on to our next topic, which is an update from Philip on some of the work that's you may have seen happening of late to reduce some of the technical debt problems that we've had in the backends, and some of the other work that's going to be coming up in the short term to further that work, plus perhaps some other build changes and that, and code formatting and that. So Philip will just give an overview of what's happened and what's to come in the short term. So Philip, take it away.
Thanks, Errol. This is going to be super informal. I'll go ahead and share my screen. Okay, I think that's the right one. Are you able to see the Zenhub board?
Yep.
Okay. So this was, I guess, quote unquote, called the Housekeeping Initiative. Around 2 months ago, we started going down this road with the goal of reducing some of the technical debt that we've built up over the years. In particular, the code base is now more than 2 decades old, so it does need some loving in some areas to be consistent across the platforms, to make developers' jobs easier when onboarding, to preserve conceptual integrity, a lot of dead code cleanup, documentation, testing, etc. So we launched an initiative about 2 months ago to hopefully involve all of the devs working on the code base to pitch in and try to clean up some of the issues that we've identified. We started as Zenhub to kind of collate everything into an easy to find place. It's currently just hosted on just a repo that we created on my personal workspace. And it's tagging, I think, issues from both OpenG9 and OMR. But if we just take a look at the OMR ones, there's epics for different cleanup items in different areas. For example, cleaning up of J9 project specific if-defs, testing improvements, documentation, conceptual integrity, improving Trill, unifying the codegen control and some RAS improvements. And then we have pipelines for where some of the issues that we've opened up in OMR and where they land. So I guess part of this is, I guess, a call to action. If you didn't know that this Zenhub existed, feel free to check it out. If you're, having the itch on a Friday afternoon or something and want to clean up some code, do some kind of more mechanical type work, maybe even learn a new part of the compiler, feel free to dive in and pick an issue to work on, help us out. So I'll go over a couple of things that we did in the last month, in particular to the codegen unification, which is something I was heavily focused on. And just to give you a little bit of inspiration and kind of direction that we're headed in, and what our end goal is going to be. So we started off with the warnings as errors that Daryl mentioned, and feel free to interrupt me if you have questions about any of this. So a lot of this work is performed both in OMR and OpenG9. This one happened to have most of the work in OpenG9. There was only a handful of warnings that we fixed to get OS X up and running with warnings as errors. We then moved on. Last week, we actually merged a big PR to enable warnings as errors on Windows and Linux. So that gives us all the x86 platforms. And in particular, 3 different compiler toolchains. So we have GCC, Clang, and Visual Studio, all 3 compiling with warnings as errors. So that'll make the job easier once we move on to the different platforms. And the end goal of this initiative is to enable warnings as errors across the board in the entire project. And as part of this work, we've identified actually several bugs. I did some self-reviews and left to-dos, and we actually ended up fixing a couple. Devin was involved in a particularly interesting one in the optimizer, and collecting a list of all the different types of issues that we've identified while fixing the warnings. And this can kind of be a showcase as to what this effort is worth in the end. At the end of the day, we don't want to make the developers' jobs harder by introducing warnings as errors and having you fix dumb warnings just for the sake of checking off a box that we have 0 warnings in the build. We're actually catching real and existing issues in the code base and fixing them, and hopefully this will reduce future bugs as well. So that's on that front. While working on that, we're starting to unify much of the code generator. Started with the dependency groups, first making them an extensible class so that we can start overriding things in our downstream projects. A lot of the code across the platforms for registered dependencies are quite common. There's not really too big of differences between them. So there's quite a lot of code deleted on a bunch of platforms. For example, on ARch64, we only have two functions that are specific to ARch64 in our registered dependencies now, and we eliminated things like tr underscore platform registered dependency group, and now we just use the common level namespace tr namespace registered dependency, and we do this across platforms. So pretty much all of them, the one on ARM as well, just a bunch of lines deleted that are basically common across platforms. So this is, I guess, code reduction, easier to understand, and once we move more code into the common code gen, we can start properly documenting that and reducing some of the technical debt there. The next thing was standardization of the evaluator names. This was something even before this housekeeping initiative started. Today, all the evaluators have the exact same name across all the platforms. So it's the IL followed by the evaluator keyword. There's still quite a lot of work to be done here, and that we can inline a lot of the code that's currently present in these stub evaluators into the actual evaluator itself. So that was part of this cleanup type work, making things look the same across the platforms, making it easier for developers to work on multiple backends at the same time. Other work we did, unifying of the instructions. So this started a couple weeks ago. Several of pseudo instructions were common across all the backends. For example, register associations, the invalid opcode, a double word defined directly in the code instruction sequence, things like fences, labels, and start of procedures and the returns. These are common across all the platforms. So we went in and changed all the platform-specific ones to the common ones. One caveat here is that they're all actually lowercase, which might be a change for some platforms, which used to uppercase things like fences and labels and things like that. Of course, we can change that in the future if we decide to do that as well. And that was kind of where we're at right now. We're still working towards unifying the instruction level APIs, putting in particular x86 and ARM. We're using their own custom classes for representing instructions. So we're unifying that to use the tr inst opcode class. That work is almost done, and as soon as that's done, we can keep on migrating APIs from each particular cogen into the common cogen, which will definitely reduce quite a lot of the technical debt that we have and duplication. And I went ahead and wrote just a couple of things that we'll be working on in the short and kind of medium term. We plan to enable warnings as errors on all the platforms. We'll probably be working on Power or S390 Next. And once we have all the platforms with -w error, we're going to circle back and turn on all the warnings and see what we come up with, and whether it's worth our while to fix literally all the warnings and turn on W all as well. Of course, some of the warnings like using offset of on non-POD data types and things like that, we're just going to disable for now. So we can disable warnings in our CMake definitions as well if we encounter some pesky ones that are probably not worth fixing or that introduce too much noise into our code base. Other things on the CI front, so this has been a long-standing issue, which GitHub actually fixed late last year. So currently we have on our actions, we actually use a custom action for our pull request labeler and, for example, the first-time contributor. And it's an action that runs on a cron job periodically, I think every 10 minutes or so. So you might have noticed that there's a delay between when you open the PR and the bot comes in and automatically labels the PR with the appropriate targeted labels or the components. So we actually had to use a custom action for this because prior to GitHub updating this, there was no way to run an action with write access to the repo to add labels. And to add labels, you need to have write access. This was a security hole because they were afraid that people from forked repositories creating pull requests and modifying your action to do arbitrary things to the code base, and this was a huge security concern. So we had to do it instead in a cron job, which basically scans all the PRs and puts the labels that way. So they actually introduced a new way of doing this, so we can actually have a proper pull request action now, which runs on the pull request itself and does that immediately. So there's no need to do this 10-minute delay, and then we can start using the actual official labeler action, the official first contributor action from GitHub themselves. So we plan to do some work on the CI here as well. Next things is, I believe, formatting. So this is the big one. So I've been doing some work in the background to figure out what has changed since, I think, 2018, the last time we made a push to format our code base in an automated way. And there's some interesting new developments since then. It seems GitHub Actions have actually improved quite a bit since we first had that initiative. And I found some interesting stuff from some projects on GitHub. It looks like there appears to be a way to have basically zero cost to contributors in terms of formatting. One of the gripes that we had previously was that people had to install Clang format or whatever formatting tool we chose locally on their laptops before submitting contributions. Otherwise, the automation would run on a pull request, and it would be a failed job basically, which tells you, hey, here's the diff that you need to apply to your commits to fix up the formatting. However, with GitHub Actions, it seems it's possible today to have the formatting happen on the GitHub action, and the action itself pushes a new commit to the pull request with the fixed up formatting. And in fact, I believe that if you have multiple commits, we can actually rewrite the original authors or the original contributors commit with the proper format and force push that to the actual branch. And this means that you don't actually have to install any formatting tool locally. You can keep working however you work today or in whatever format you'd like, submit a pull request, and the tool will go in and format all your commits for you and force push to your branch, your PR branch. There's also alternatives, for example, that are discussed here, in that you can choose not to do force pushes. You can get the tool to just add a commit, which fixes up the formatting. And then instead of creating a merge commit, we can just simply squash that formatting commit away when the committer merges the pull request. So there seems to be various different ways that we can handle things with new and improved actions, and hopefully in the medium term, probably towards the end of the year, I hope to make another push towards automated code formatting, and we can have some different ways of doing it on the table and decide as a community what we think is the best way forward. So that's that on the formatting front. I think other work is unification of the mnemonics and instructions, encodings, and properties across the platforms. So we're probably going to adopt a similar thing that x86 does today, actually, and that we do for our IL, where we use macro generators to define what IL is, or I guess the instructions in this case will be across the platforms, and then have a consistent way of defining this macro and generating the various properties, mnemonics, for example, architecture level sets, or anything else that you might want to generate on your particular platform. So for example, for IL today, for example, for the iconst IL, we define a macro called opcode macro, and then various things that we want to know about the iconst IL. And then to generate this in various tables, we would just redefine what the opcode macro is. So for example, for just the IL, for the properties, we take the entire opcode macro and generate something that looks like basically this. So we can do a similar thing for the instructions across the different platforms to unify that and have a consistent way of defining an instruction across the platforms. No need to go off to 3 or 4 different files and make sure that the order of all the instructions is the same and you wrote it in the correct place, etc. And finally, I think the last thing I have here is unification of memory references. Quite a lot of that code is common across the platform. So once we have instructions in place, we can start to unify memory references as well. Dynamically allocating register dependencies and being a little bit smarter about dependencies overall. I'm sure most of you have encountered code in our evaluators, which count the number of dependencies that you might need and then create a register dependency object with the exact count. I think this might be overkill. We can just do this dynamically and avoid quite a lot of the churn of counting how many possible dependencies you might need. We can just dynamically reallocate underneath the hood. Other ideas that were proposed by Daryl is having high-level APIs, for example, generate, add instruction in the common cogen, which would then be overridden in the various backends and generate, for example, an addition. So this could be a faster way to prototype evaluators across platforms, which are usually quite simple. They typically have some, using OpenGNM as an example, for example, in, I don't know, a checkcast evaluator or an instance of, it's basically just checking pointers, doing some bit twiddling and branching to different places. All of this can be done with more high-level API, and then that enable us to bring up platforms like Pers5 much faster than we do today. And then, of course, platforms can override these things and implement a super fast sequence, because doing something like this might not be quite optimal. Other things we want to tackle is compiler tests. We want to deprecate them in favor of chub tests and start writing a bucket of tests for each and every opcode that we have in the code base, because I don't think we have full coverage today. And a little bit more love to the build system to fully migrate it to CMake. I know we use Makefiles today for some of the projects, like the linter and I think pieces of the compiler test and the JIT builder. So we can hopefully migrate fully to CMake and take advantage of that. So a lot of talking for me. I don't know if anybody has, this is just probably a piece of all the stuff I could remember or write down. It's basically a very fluid to-do list that always keeps changing. And yeah, just looking forward if anyone has the itch to come in and help the cleanup and housekeeping effort. We're welcome you with open arms. That's really all I had.
Thanks, Philip. There's a lot of good stuff there over the last couple of months, and certainly looking forward to some of the others, these other changes landing in the coming months as well. So yeah, I'll also echo his invitation that anybody that wishes to work on any of this stuff, there's certainly a healthy backlog of tasks that can be taken on if you like. So, any questions for Philip? Okay, if not, those were the only two topics that we had for this week. I have created the issue for the next architecture meeting in 2 weeks. So if there's any topics that you want to suggest, I should say, please add them to that issue. And other than that, that should be it for today. So thanks everyone for attending, and we'll talk again in 2 weeks. Thank you.
Thank you.